Okay, now that we've established why statistics is important, let's actually define what statistics is. What does the word mean? And then think about what it means to actually think statistically and kind of have that mindset as you approach a study. So let's see here. All right. So we have some terminology in statistical thinking. Well, this definition is according to Professor Ron Larson, and I like it. It seems to encapsulate all the components. But statistics, then, is the science of collecting, organizing, analyzing, and interpreting data with the purpose of making decisions. I want you to notice here that there are 5 pieces to this definition. We've got, let's see. We've got collecting. So how do we get the data? We're going to go get it. Then once we've got it, how do we organize it? You know, if you think about sitting out and just observing what kind of cars people drive, you might have a paper with a bunch of car manufacturers on it in a seemingly random order. Well, how do you organize that information? Once it's organized, how do we analyze it? If it's analyzed, what is it saying to us? And then how does it inform decisions? This is sort of the big key here. To be honest, the decision piece will typically be outside of our pay grade, but we will be doing those first 4 pieces and then make a recommendation to someone who actually might want to make a decision regarding the data that we've collected. So that's what we mean by statistics. It's the science of collecting, organizing, analyzing, and interpreting data for the purpose of making decisions. There are 3 components of statistical thinking: preparation, analysis, and conclusion. What do we mean by preparation? Well, what are we trying to study, right? That's important. What is it that we're actually trying to study? And what's the goal? We have context. We have the source of our data. Where are we going to go get it? And then our sampling method. How do we collect our data in a way that eliminates or at least minimizes bias? Do we have enough data? How big a sample do we need to get? This is all preparation. Analysis. Once you've got your data, what is it telling us? You know, we might explore with a graph. You have certain types of data lend themselves to different graphs, and those graphs can be very informative. Explore. Is there a number that would serve as a good representative of our data? Perhaps an average or mean is the best number to represent it. Is there a number that tells us what values fall in the middle or occur the most often? How different is the data from itself? Are the numbers wildly spread out, or are they all clustered together around some other number? We might look at the variation. How do we quantify that? This is all part of exploring. And then applying statistical methods. This is really going to come up in the 3rd part of the course, but you know, these statistical methods might involve some type of technology, but they also will involve some type of inferential technique. You know, granted we have this sample, but what is it telling us about perhaps a larger population? And then the conclusion. We have the study we've explored. Are the results statistically significant? Are they also practically significant? What do I mean by statistically significant versus practically significant? Well, a result is statistically significant if it's unlikely to happen by chance. You know, I'm suffering from headaches, and I'm suffering from headaches 3 hours a day. I take this experimental drug, and now I suffer only 10 minutes in the morning. Take the drug and it's gone. That would be a statistically significant result. Practical significance, on the other hand, is an effective treatment whose implementation does not violate common sense. Yeah, maybe my headaches have decreased dramatically, but maybe now my heart rate is dangerously low, or my blood pressure is dangerously low. Great, I don't have a headache, but my heart's about to stop. Not practically significant. Other example, you may have a treatment that increases the chance of something happening. Maybe you and your spouse are trying to get pregnant and you want to increase the chance of having a boy. Let's say that the normal chances of having a boy are 51%, and you go through this treatment and it ups your chances to 53%. Well, if the treatment costs $10,000, is $10,000 worth that 2% increase? I'm gonna guess not. You know, if it were maybe a 30% increase, maybe. But for a mere 2% increase, I don't think most people would spend $10,000. That would be not practically significant. Perhaps this is the way my brain works, but you'll have to forgive me for the next example. When I think about keeping statistically significant results and practically significant results straight, I often recall a horrible police show I used to watch in my childhood. Through the wonders of YouTube, I've managed to actually find it. So this example really, in an absurd way, articulates the difference between statistically significant and practically significant.
What's going on? I gotta get the got a sniper on that roof. No good yogurt eating freak. Building back in the area. We got vermin on the roof. I got an idea. Who are you talking to? Nobody.
Okay, so obviously absurd, but again, if there is in this case, a sniper on the roof or something, some threat in a building or on top of a building, demolishing the building will certainly neutralize the threat. That's not going to happen at random, and the threat taken care of, right? On the other hand, who in their right mind is going to do that? It's absurd. So in a very hopefully slightly humorous, in a 1980s sort of way, we see the difference between statistical significance and practical significance. Thank you.